All right, so now we're looking at, as it says there, geometric sequences. So again, sequence, just a list of numbers. And so geometric suggests the word is multiply. So a geometric sequence is one where you get a term by multiplying the previous term, excuse me, and it's a common ratio. So when you have a look at this one, times by 2, and then if you times that by 2, and then if you times that by 2. All right, so the first one, our common ratio, would be 2 for this one. Now, the next one we've got there, it's this one. To go to 50, we'd be dividing by 2, but then it comes negative, so divide by negative 2. Here, divide by negative 2 again works. And again, dividing by negative 2 again works. However, we don't think of geometric sequences in terms of division. So if we are dividing by a number, in this case we're dividing by negative 2, we need to think about the equivalent of multiplying. And so the equivalent of multiplying would be multiplying by a negative half. And if you like to think of, if you're dividing by negative 2, that's negative 2 over 1. And if you're dividing by a fraction, you multiply and flip it. All right, so R, in this case, would be negative a half. All right, because we're always in terms of multiplying. All right, so if you're dividing by 3, then you're multiplying by a third. All right, and so we use R as 1/3 in that case. All right, so to get the next term, we'd take this term and we'd multiply it by. All right, so 12.5 times by half, and then 6.25 would be the next one, and so on. All right, now if we go further, so this is recurrence relation. If we wanted to use so this one's recurrence. All right, how you get the next one from the one you've got, and this one's our explicit. All right, so that tells us the term number in relation to the terms. All right, so again, we need to know our first one. We need to know our common ratio. And again, we've got n minus 1, because of course, remember, to get term 1, the 2 here, change back to me blue. So to get term 1, which is this 2, you don't have to actually multiply that by anything. So term 2, you're going to multiply it by that common ratio, but only once. So term 2 minus 1 is 1. All right, so there's our two formulas that we might need to use. Let's have a look at some examples. So find the 10th term of the sequence. Well, we know the first term is 2. And this one's pretty straightforward. We know that it's 3. But if you're not sure, what you can do is you can just take two terms, any two, as long as they're next to each other, and you take the bigger one, 6, and divide by the one before it. I say the bigger one, the biggest term number, not the biggest necessarily number, but biggest term number, in this case term 2, which is 6, divide by the previous term, which is 2, and you get 3, and that will work for everything. So if you're not sure, you can work that out. So like up here, for example, if I wanted to do it, it doesn't matter what pair I can go. Let's go this one here and this one here. So the third term was 25. The second term was negative 50. 25 goes into itself once and there twice, so that's negative 1/2 for our ratio. All right, so now we've got our ratio, and we know that n equals 10, and so term n is AR to the n minus 1, so term 10 is 2 times 3 to the 10 minus 1, which is 2 times 3 to the 9, and that's a calculator job, and you get 39366 after you've done that on your calculator. All right, let's have a look here. So this one here, geometric sequence, the first term is 18, fourth term is 144. Find the common ratio. All right, so first term, T1, which of course is A, is 18. Term 4 equals 144. So using the formula again, term n equals AR to the n minus 1. Then we know when n equals 4, term 4 is 144, and that's 18 times r to the 4 minus 1. Divide both sides by 12. It's 12 equals r to the 4 minus 1 is 3. Hang on, what have I done here? Why have I put 12 there? That should be 18. Oh, lucky. Those of you who are on the ball would already pick that up. That's 18, not 12. Yeah, not 12, 18. All right, 18. 18. So we're dividing by 18. I was hoping it was 12 because I was going to make life easier for myself. All right, so when you divide that into there, it actually goes in 8 times. 18 goes into 144 8 times. And so now we need to get rid of that cubed, and opposite to cubing would be cubed rooting. So the cubed root of 8 equals r, if we cubed root both sides. Now the cubed root of 8, number that multiplies by itself 3 times to get 8, that number is 2, of course. All right, so the common ratio then is 2. All right, sorry about that. Writing down that wrong number, it's terrible. Anyway, we move on. All right, the third term of the geometric sequence is 10. So term 3 equals 10, and term 6 equals 80. All right, so let's have a look then. Let's write it down. Term 3 is 10, so 10 equals AR n minus 1, 3 minus 1. So 10 equals AR to the 2. Term 6 is 80, and 80 is AR to the 6 minus 1. Nearly got ahead of myself because it's AR to the 5. All right, this is equation number 1. This is equation number 2. So you could be expected, there's 2 unknowns, you could be expected to do this by hand. Now, because these are multiplying here and here, the way that we do these by hand, we're used to just solving simultaneous by adding, subtracting. But you can also divide, and that's because this is a times. That's the strategy we use here. So we would take equation 2 and divide it by equation 1. And so you get 80 over 10 equals AR to the 5 A r to the 2. So 8 then that side there, the a's cancel. Index law, when we're dividing, we take away, so that's r to the 3. And so from what we know then is that r has got to be equal to 2. And then we need to know what the first term is, which is a, and so now we can just go and substitute in. I'm going to choose equation 1, doesn't matter which one we do. So I know that 10 equals 2r squared, divide by 2, divide by 2. So 5 is r squared. And where are we? Yep, that's right. Oh, hang on. I'm not having a very good day today, am I? It's, A is not, R is. Get rid of all of that. Get rid of that. R is 2, not A. So 10 equals A times 2 squared. 10 equals A times 4. Divide by 4. Goes into itself. 2 goes into 4 twice and into 10 5 times. Cancels there, the 4's. So A is 5 over 2. All right, I'm not concentrating. Need to concentrate better. All right, you'll see at the bottom here, compound interest. Now, compound interest, which is very common sort of interest, is a type of geometric sequence. All right, get interest on your interest. And so when you're doing compound interest, A is the amount that you invest, and R, the common ratio, is 1 plus the interest rate in percent on 100. All right, the 1 plus, the 1 is you still got the amount of money you put in plus how much you earn for the interest, and so that's where that comes about. All right, so if we have a look at an example, and this is Marta. Marta invests $2,500 at 7% per year. The value after 5 years. All right, so A is how much she invests. And she invests 2,500. R is 1 plus our interest rate on 100. And so that's 1 plus 7 on 100, which is 1.07, which we will use as that. And so the question here is, how do we work out what N is? After 5 years is what she's got. So that's what we want to know. What's N? So what we've got to think about is how we're doing our N. So term 1, you need to think about that as being what you've put in. So term 1, which we've said is the A amount invest, is 2,500. So for this one, then after 5 years, so that then means that N is going to be equal 6. All right, so it's a kind of a bit of a weird way of doing it, but with the way that it's set up, that's how we and the formula, and that's how we have to do it, is by term 1 being the start, so time equals 0 is term 1, then another 5 years, so N equals 1 plus 5 is 6. All right, so how much is her value after 5 years? So the 6th term would be 2,500 plus, not plus because this is geometric, so times 1.07 to the power of n minus 1, so 6 minus 1, 2,500 times 1.07 to the power of 5, and that's a calculated job. And when you do that, you get $3,506.38. All right, and in this particular question, and any questions involving money, so it's money, so what that means is 2 decimal places. All right, that's a given. All right, we do things in dollars and cents, and here's the cents, so we need to now, back here, we're not interested in if there's any more. So you need to always, for money things, round off to do decimal places, unless you're told otherwise, of course. All right, part B says, how long until investment is worth $10,000? All right, so B. All right, so we know A is 2,500. We know R is 1.07, and we know term N is 10,000. And we want to know N. So if we set up, term N is 10,000, and that's equal to A, 2,500, times 1.07 to the N minus 1. All right, so again, this is going to be a calculated job. So let's go calculator again. Here it is. Solve. What are we solving? We're solving 10,000 equals 2,500 times 1.07 to the power of. Now you'll have to put this in bracket just to make sure. X minus 1. All right, so you want to make sure that that power is x minus 1, so make sure you put the bracket around that so it puts it both up there. Solve that for x for me, please. And there we are, 21.49 years. So, or 20n equals 21.49. So what does that mean? When will the investment be worth 10,000? Well, it will be worth 10,000. Remember, A is 1, so if we take 1 off that, so term 1, and so if we take 1 off that, that's 20.49 years. So 20.49 years. Now, so the way we would write that is that you would say that it becomes worth $10,000 in the 21st year. All right, because we don't actually work at parts of years in the question. It's in this case, you get your interest at the end of each year. So mathematically, though, that becomes 10,000 in part of a year. All right, so we just say in the 21st year it would be worth that. So the reality is after 20 years it's worth a bit less than 10,000, and then after 21 years it's worth a bit more, so during that period. All right, so that's that. All right, the last thing is geometric means. All right, so geometric mean is a similar idea to the arithmetic mean, but rather than adding, we're multiplying things. So this in the middle here is the mean, and because we're multiplying two things together, that's where the square root comes in. Remember, for the arithmetic we added and then we divided by 2, so now we're multiplying, and so we've then got a square root. All right, so C would be, which is the middle term in between A and B, is the geometric mean, and so you multiply by the same ratio there. So here's an example. Geometric mean of 7 and 175. So what that means is we've got 7, we've got some other number, we'll call that C, and we've got 175. So this one here, this C, would be the square root of 7 times 175, and that's a calculated job because that's the square root of 1225, which is square root of 35, and so that's definitely a calculator job. All right, so that's it. Geometric. So geometric is multiplying by the same thing all the time. As always, have fun, and if you need help, get back to me.